Yeah, well, Chili here, and it's time for another update video. You might have noticed, Chili, there hasn't been a lot of videos in the last few weeks. And true, that's pretty true. I've been busy. I'm busy with work, Kid, family is always gotta be, take your time, that's the first priority. And then work is getting a little hectic. We had a release, so there's a lot of stuff going on there, and I got kind of like put on like two different projects at the same time, so it's really been eating up my bandwidth. And then whenever I have like a little bit of free time, I'm like, I'm too tired to start like trying to figure out some direct 3D 12 stuff or some multi-threading or whatever. I just want to relax, man. So it's gonna be a little bit before we get some more new videos. I got to get more back into the pipeline and stuff like that. But, in light of the drop in output, and do my usual thing, pausing the Patreon. So just a little heads up for you Patreon guys to support me. Thanks as always. It's really nice to see the support. And, this month haven't put out enough really for me to justify turning that on. I'm going to turn that spigot off for a month, and we'll see where we are next month. But yeah, that's pretty much that. And when I get the bandwidth, I'm definitely going to be, my number one priority is just working on the infrastructure stuff, getting the sprite batching system to a point where I can start making videos on it. That's pretty much all I had to say. But to be ashamed to put out a video and just like 1 minute of announcement. So let me show you something that I use at work occasionally and a lot during the past week. It's a tool called GPU View. And those of you who know this tool. I mean, if you do a Google search, you'll find there's not a lot of information on it. So I don't think it's that widely known, but it is very well known to people who are working at a very low level, debugging issues with, GPU graphics workflows. So people who are doing development on drivers, and people at Microsoft doing work on the graphics APIs, Direct 3D, and the Windows kernel and the desktop compositing subsystems, and people who do very low level work on fine tuning games engines, especially for specific hardware. They are all familiar with this piece of software here. And what it lets you do is it lets you kind of peek into the black box of hardware 3D processing and kind of see what's going on in there, what's happening to your commands after you issue them. So let me just show you a little thing here, a little interesting thing. This is a trace that I took running 3D Mark TimeSpy. I think you can see it right here. Yeah, 3D Mark TimeSpy.exe. And you can see here, these are queues of basically command lists. There's more than stuff as fences in here and command lists. And so you can see as commands get submitted, the queue grows, and as they get executed, the queue shrinks. And when a command list, called a packet here, DMA packet, when it gets to the bottom of this queue, then it goes up onto the hardware queue and it's executed up here. And multiple can stack on this queue as well. So you can look at this and you can see like what is the occupancy of command lists on your hardware, and what are some possible sources of latency, interruptions, contention. There's lots of stuff you can do here. This also shows you all of the CPU threads, so you can see the CPU load versus the GPU load, and you can see possible points of synchronization between those, when the CPU is blocking on GPU work, when the GPU is blocking on CPU work. Lots of cool stuff in here. So let me show you what I got here. So this is, like I said, I'm taking a trace of 3D Mark TimeSpy. But I've also got another program running that is putting an overlay on top of that. So that's this one here. It's drawing on top of the screen of this game. This game's running full screen. I got a little like heads up display running on top of that. It only runs periodically. Like I think it's running at like 15 frames per second here. And it's interesting. We can see that TimeSpy 3D Mark, its commands are going on its own hardware queue. And our overlay, which is running with DirectX 11, gets its own queue here, does a little work, and when it presents, that actually triggers a packet DWM to do some composition work. This is working using MPO, multi-plane overlay. And then we get this presenting here. And so we have two overlay layers here. And they're just composited one over top of the other. It's kind of neat here. You can see that these queues actually run concurrently. So here, when we're executing these packets, if we look on the second hardware queue here, we see it's empty. So the GPU can work exclusively on these packets, and they're very short. But now look over here, where the execution times overlap. It takes a lot longer to execute the packet. So we can see that they're running concurrently, but they're also, contending for resources. Now we take another trace, which is running the same overlay, but on Dota 2, which is running with DirectX 11. And we no longer have those two separate programs running on separate hardware queues. They all go in the same queue. So here is the overlays rendering packets, the command list that it's executing. And then here's Dota. And what you see here, this is very interesting. We still have the two overlay layers. Here is the Dota's presentation packet, its flip. Here's the one for the overlay. And what's interesting is overlay finishes its work, but the flip doesn't happen until way later. It's delayed for whatever reason. And when you hit this flip here, Windows is going to put this packet on the queue, and it is a preemption packet. And that packet actually cancels whatever work Dota was doing. It says, no, stop that. It does like a Kanye interruption. I'm going to let you finish. But first, we got to let my boy DWM here do a presentation. And that basically, so if things were working as we would like, Dota 2 would finish its work maybe somewhere around here, and then this present would come in here. But instead, it gets interrupted, and then it has to reschedule its work. And so eventually, Dota 2 doesn't finish until here. So its present gets delayed by maybe like this much. So like 1.2 millisecond delay on the present, that's not great. That's pretty bad. And that's just interesting little difference between these two scenarios. So yeah, that's what I'm digging into here. To reiterate, sorry for the lack of videos lately. It might continue on for a little bit longer. I'll be pausing the Patreon, but we will come back and we will be doing direct 3D12 stuff for sure, and probably some more multi-threading as well. We're gonna have fun. In the meanwhile, I might release a couple of videos on ROM hacking, but I don't consider that enough to turn on the Patreon spigot. So until next time, have a good one. See you later.